All right, so t squared, whoops, minus 10t plus 16 equals 0. Does it factor? It doesn't?
Oh, well, I didn't do that. I just did the quadratic formula.
Oh, quadratic formula is nice. Always works, right?
Yeah.
It does factor, though, Jack says. T minus 8, t minus 2. So either t equals 8 or t equals 2 is 1 equals 0. So quadratic formula, factoring. If you were not algebraically inclined at all today during 8th period, you could have done Calc 0, right? I don't think there's any reason to do Calc 0, but you could have. All right. So we now know when the velocity is 0 at 2 and at 8, but 8 doesn't really matter, right? Because we're not looking at that. All right.
So the way I kind of saw it was that since the a value or the leading coefficient was positive, it has to be positive from 0 onwards until it hits the 0. So I said that x was positive when it was greater than or equal to 0, or less than or equal to 0, 2.
All right, so positive on 0, 2. Yeah. And Asa used some interesting reasoning, right? He said the quadratic is opening up, so it has to start positive, go negative, and go positive if it does that. Yeah. All right. All right. And so what's that? Negative on 2 comma 6. All right. Great. I guess you could actually argue maybe those should be parentheses. Like, is it increasing or decreasing at 2? Or is it positive or negative at 2? Well, it's 0 at 2. It's not negative. It's not positive. I don't know. Okay. All right. Great. Derek, how'd you feel about B? Talk to us a little about B.
So they asked what under this times you have this covered in the integral.
All right.
So you set up the integral for 0 to 2 and then for 6.
All right. So this is 0 to 2 of v of t dt, and this is 2 to 6 of v of t dt. Some people doing it by hand. I thought. Is that true? Let's do one of them by hand, and then we can just say what the other one is. So 0 to 2 of t squared minus 10t plus 16. Notice I picked the one that had 0 in it. All right, so the integer of t squared minus 10t, and then plus 16. All right, from 0 to 2. Plugging 0 in is going to get me 0 out. Plugging 2 in, what's that? 8/3 minus 20 plus 32. Negative 20 and 32 is 12, and then I'm going to add 8/3 to that. So what's that? 14 and 2/3 you said? All right, so that's 14 and 2/3. Okay. Yeah, what are the units on this?
Feet per second.
Velocity is feet per second, and the time, so this is feet per second, and this is seconds, so yeah, it's going to be feet. All right? And that's representing right there. Now, from the next interval, you could either do by hand, or you could just do Calc 7. Adrian, did you get from 2 to 6? Negative 80/3. What's that like? Negative 26 and 2/3. All right. All right, so I think now we're ready to talk about, well, so all right, that was B. Any questions for B? Derek and Adrian sort of took care of that.
Wait, I got negative 25.
Negative what?
25.
Negative 25 and a third. Double check, because I heard I heard the majority saying negative 26 and 2/3, so maybe just do a Calc 7 or something. All right. Kaylee, how do you feel about the difference between C and D? You want to put together like, you don't even have to do either one of them, but maybe tell us what you thought the difference was, and then maybe Talia and Will can tell us what they got.
Let me get that.
Okay. Do you want to try it? Definitely not? Talia, you want to tell us the difference between C and D?
Well, the only difference I got was negative versus non-negative.
All right, keep talking.
Well, it was kind of funny because I got negative, which I assume meant that object kind of travel backwards, like if a train needs to reverse because it goes past the station or something. Without stopping, I don't know if that could be the situation. So that, because it was a little bit weird, but I thought, so that means the displacement of the object is the distance from the starting point to where the object ends up.
Okay, so let's pause on that because that's great. So Tali says for D, the displacement is the distance from the starting point to wherever the object ends up. All right, so in other words, you could have like a runner running around a track, and when they get back to the starting line, the displacement 0. The distance between where they started and finished is 0. There's no distance between where they started and finished. That's called displacement, and that's a physics term. Distance is, the 400 meters that the runner ran. Like the runner actually ran 400 meters. It just so happens that he or she ended up 0 from where he or she started. Gabby, follow-up question, or do you want to comment? Okay. All right, so based on that, Kaylee, do you want to try to do C or D, since we have this notion that, let's see, we took 14 2/3 steps forward, and then we took 26 2/3 steps backward. So do you want to do displacement or distance? And I don't care which one you pick.
I guess displacement would be negative.
Okay. Displacement would be negative. Is that, you just subtract them and you get negative 12? All right, so for D, it's negative 12, and that means we end up 12 steps back from where we started. People okay with Kaylee's answer? Yeah, go ahead.
Wouldn't it be 12? Why do you need an... Okay.
So displacement still has positive or negative, because a displacement of 12 tells us we took 12 steps forward. Right, and so negative 12 tells us we've taken 12 steps backward. Displacement is a vector in science, and that means it has, the sign value is important. It tells us direction and magnitude. Is that all right?
Yeah.
All right, Will, you want to knock off C? 40, what is it? 41, wait, 40 second? 41.4. It's not 0.4. That's impossible. 41 1/3, is that what you wanted to say? Yeah. All right. Isn't it something in a third?
Yeah, it's 41 1/3.
All right. And that means how many total steps did we take? Well, we took 14 2/3 plus 26 2/3. So we're actually adding those. Do you want to ask a question? All right. Now, this is the difference. Displacement and distance is the difference between looking at the definite integral, being positive and negative, and looking at the area, meaning just positive. And if you remember, if we were to do it on our calculator, right, your calculator is not going to tell you what the total distance is unless you get a little clever and you do second insert, math, number, absolute value. And now if you do the absolute value, it makes everything positive. Like it makes all of the steps forward. So how many steps did I take? Well, it's counting your backward steps as forward now, which is helpful to find the distance. And if we do Calc 7 and go from 0 to 6, right, there are all the forward steps, and we get 41 1/3, even though it looks like it's rounding a little. Okay? So your calculator can actually do that for you too. Otherwise, if you're doing it by hand, you have to break it up into the intervals that it's moving forward, intervals that it's moving backwards. Think about displacement, think about distance, and answer that question. Is that all right? Yeah. Let's see. How about taking a look at 23? All right, Betsy, read for us.
Say Ling's car runs out of gas as she's driving up a long hill.
That's funny. That's hilarious.
Okay. She lets the car roll without putting on brakes. As it slows down, stops, and starts rolling backwards. Its velocity.
Oh, let's see. Is my
velocity up the hill is given by v.
Yeah.
Where v is p per second and t is the number of seconds since the car ran out of gas.
All right. So let's look at this from 20 to 40. Just out of curiosity, where does it stop going up and start rolling down? Mm-mm.
At 0, doesn't it?
Mm-mm.
30.
Yep. How'd you get it?
Alright, equal to 0, and then you solve.
When is the velocity 0? When t equals 30. So 30 is when it stops rolling up and starts rolling backward. So it wants the displacement between 10 and 40. Displacement, do I need to worry about positive or, do I need to worry about making everything positive? No. So I can actually just do 10 to 40 of 60 minus 2t. All right, Zach, any differentiate for me? Yeah, I think you did too. Minus, wait, what is it? Just minus t squared. All right. From 10 to 40. All right, so that's 2,400 minus 1,600. Is that when we plug? Isn't that it?
No. That would be 600 minus.
It's 800.
Wait.
500.
What? I'm not done yet. Minus 600 minus 100.
Oh, yeah.
So it's 800 minus 500. Is that okay?
Yeah.
I have two people saying yes. Am I all right? You're usually my super math arithmetic person.
Oh, I just simplified it out to start. Yeah. 540. That'd be 240.
So do we just have different ways to get us to the same place?
Yeah, it's good.
All right. All right, Jack. So what about total distance? Gesundheit.
We can just add them so it subtracts to be 800. From t equals 10 and t equals 40?
Yeah.
Can't we just add the...
You have to find when it's positive and when it's negative.
Yeah, so I actually have to know...
Where it is, where it's at 10.
Right. Where it's... No, sorry. So I need to break it up into where it's going forward and where it's going backward. We know where does it switch from going forward to backward? 30. All right, so...
Find 10 to 30 and 30 to 40.
10 to 30 of 60 minus 2t plus 30 to 40. What are you about? What's up?
I was just wondering if you don't need to actually write that separate.
So, look, this doesn't say, right? Like, if I asked you to show all your work and justify your answer, the answer should be, yeah, of course I can do that. And you actually gave me an easy function. If you want to go do it on your calculator now, you can do it on your calculator now. I'm all right with that. But with great power comes great responsibility. Yes, Asa.
So when you put absolute value signs around the integral.
Oh, so Ace is saying another way of doing it would, well, this is This is actually the same thing, is to say this is equal to, from 10 to 40, the absolute value of 60 minus 2t dt. These two sides, taking them, actually, I shouldn't say that. That's wrong. I actually have to take the opposite of this value, right?
Yeah.
Because this value is going to be negative.
So you put
So I have to, flip it.
Yeah.
Okay. Yeah, you're right. So I would need...
You don't even need to put negative.
Is it really?
Well, it should be because that first one's positive. You know what I mean?
Because you get 400 plus negative 100.
I got 300 last. I don't know.
Well, wait, hold on.
It should be 500.
Yeah, I got 5.
Okay.
It should be.
Yeah. So if it rolls forward 400 and then backward 100, that means its displacement from where it started is 300, but its total distance should be 500. Right? The 400 plus the 100, not plus negative 100. That's the conversation Ace and I were just having.
What happens?
What are you, leaking quarters? Yeah, go ahead.
No.
What happened to the negative? Is that was your question?
No, I already.
Are you sure?
Yeah, no, I'm
Positive?
yeah, my brain is.
It's the end of the day. It's understandable. It seemed like it got a little confusing at the end. Are we all unconfused, or do we need to say anything more? All right, and why don't you finish it off? Why don't you do 24? Actually, you know what? I should say something. I'm going to say something. I'll make it official. Okay, so first semester, you learned that, let's see, acceleration is the derivative of velocity, which is the second derivative of position. You learned that velocity is the derivative, why am I not saying, I'm saying this all wrong. All right. Velocity is equal to the derivative of position. That's what I wanted to say. I was not saying it well at all. Acceleration is equal to the derivative of velocity, which is equal to this. Oh, that's what I wrote before.
Yeah, you had it right. I don't know.
I was messing, but it didn't seem right. Okay. So what we know now is we can just reverse all this for second semester, right? So now we know that the integral of velocity, and maybe, you know what, maybe I'll just say the antiderivative of velocity, is position. And we know the antiderivative of acceleration is velocity. Right? So we can move forward and backward now. And that's sort of nice. You have to keep it straight, though, because there are like 3 out of 10 calc students that get it mixed up. Like they take derivatives when they should be taking antiderivatives, or take antiderivatives when they should take derivatives. And if you just go back to like last year and think of rates of change, like velocity is feet per second. It's the rate of change of position. It's the derivative of position. All right. All right. Now I'll say do 24 and we'll finish this up. Should we do it? Maybe we'll do it together.
What is,
No, let's do it. Never learn when we do it together.
That is not true. You never learn when we do it together?
It's easier for me to find out where I screwed up and then go. Does A stand for acceleration?
Yes.
Okay, I just want to be clear.
Yeah.
And V is velocity.
Yes. This is my astronomy friends? Is that all of you? All right. Busy week or not so busy week? Was last? Are you kidding me? Wow. That's tough. Like if you're absent or something. I don't like tests to do before.
It would be so much better if I just had that service. Like, I'd much rather have it on
Wednesday.
Wednesday.
Have the test on Wednesday?
I mean, if we weren't going
Yeah.
to that thing. Cause like, we have a Charlotte last
That is brutal. Oh my goodness. No, don't do that.
Actually, last test that worked out really well.
it did
for
work
me.
really well though.
Educated guesses, though, right?
But they're like so long. You're just like,
I never know what he's talking about. I'm just
You're
doing
just
like
saying.
All right, Gabby. Can you start us off?
Oh, it's V of 0.
Are you sure? Well, look, we did say this. Right? We know that the antiderivative of acceleration is equal to velocity.
Yeah.
So,
Wait, I'm like.
So
Well, I didn't regard that into
the antiderivative of root t dt. You can do that. Talk me through it, Gabby.
42 with the antiderivative of root 2.
Yeah.
2 thirds t to the 3 halves, or the 3 halves t to the 2 thirds.
Which one?
2 thirds.
2/3 t to the 3 halves. But don't stop there. Nope. Oh, yeah, you're right, but not yet. Just say plus c. So this is the difference between definite integrals, which are a number, and antiderivatives, which are functions. So the velocity is a function. We need to find out what c is. All right, so they've given us some information here. V of 0 equals -18. Now that was a very nice piece of information to give us. Would you agree? Mm-hmm. Giving us the initial condition actually tells us, in this case, what c is. So V of t is equal to 2/3 t to the 3 halves minus 18. All right, so Liz, how are we going to tackle B? That's all right. We'll do it together. Just talk to me. It's actually a two-part question. All right, keep talking. What would you do? Yeah, so this is definitely screaming definite integral. The displacement and the distance are numbers, so we're going to get the definite integral. So position. Well, so all right, keep talking. What do you want to do? Yep. So the displacement, in a sense, is a little easier because you don't have to worry. Right. Like displacement, just where'd you end up from where you started from. I don't know that it would be that hard to do by hand. But Liz's call. All right, so here's another thing that sometimes calc students mix up. To find position, you take the definite integral of velocity. Sometimes students are so overzealous that they do the antiderivative, find the position function, and then do the definite integral of the position function. The definite integral of the position function is nothing that we need to know. We need the definite integral of velocity, which was, what was it, Gabby? 2/3? All right, 2/3. Oh, shoot. I would need it too. 2/3. And I think I'm just going to put to the 1.5 and then minus 18. And I think it was from 0 to 16. I don't know what my y is going to look like, so I'll just graph it and see. Looks like something's going on around 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think I have to go down a little bit further. Maybe -20. I don't know if that does it. Oh, good.
Well, you knew it would be -18.
Oh, yeah, of course. Why wasn't I thinking? Of course. All right, so if we want this definite integral, Calc 7, from 0 to 16, about -14.9. So that, no, that's, what question did we answer? All right, Liz wanted to do displacement, and that's -14.9. So this says, where do we end up from where we started? About 15 steps back from where we started. The distance, the total distance, you have to count steps forward and steps backward, and so that's like as both as positive. So you have two choices. You could do absolute value, or you could do 0 to 9 and 9 to 16 and count them as both positive. What do you want to do? All right. So I'm just going to second insert the absolute value, and let's see. Oh yeah, all right. And then let's see. Calc 7 from 0. Oops, 70. That's crazy. from 0 to 16. And so now it's counting all the backwards steps as forward, and all the forward steps as forward. Wow, that's a lot of steps. 179.5 steps. Whoops. All right. So the total distance is 179.5. All right, so the rustling tells me we must be close. All right. Hey, great work. I don't know. Yeah, Wednesday.